Hello everyone, welcome to Maths IEC. Here's another possible A-level exam style question. Please pause the video and give this a try. When you want to check the answer, press play. This resistor network is connected to a battery of EMF 12 volts. So let's mark this one here, 12 volts, and internal resistance 3 ohms. So we know lowercase r here is 3 ohms. The switch is closed for 4 minutes. So we know the time here is 4 times by 60, 240 seconds. The question is, calculate the energy dissipated in the resistor combination. So there is energy dissipation here. We need to work out what that is in this 4 minutes. Now, I would first try to find the total current in the circuit, capital I. So that's quite easy to do. I is equal to E over R plus R. E is the EMF, capital R is the external resistance, lowercase r is the internal. So let's calculate the current here. EMF here is 12. Lowercase r I know 3, but I need to work out the capital R outside resistance here, which is the total of these two. You can use the normal 1 over r total method. So 1 over r total is 1 over 60 plus 1 over 90. So we get 1 over r total is equal to, so that gives me 1 over 36. So we know R total here is 36 ohms. Okay. So we can use that 36 here. So we know the current. So the current in the circuit here is 12 divided by 39. That gives us 4 over 13 amps. I'm not going to simplify it because I get a long recurring, just going to keep it like that. Now, how do I find the energy? So the formula for energy, I can have few of those things. E is equal to IV T or V squared over RT or I squared RT. Now, where do this formula come from? Because P equals IV. So energy is power times time. So I know the power formula. P equals IV, you multiply by time. Or P equals V squared over R times T. Or P equals I squared RT. You can use any of those equations. Now, how do I find energy? So I know the current through the circuit is 4 over 13 amps, and I know the total resistance outside because the question is energy dissipated in the resistor combination. There is energy dissipation here in the internal resistance too, but it's not asking that. So I'm just going to use the one with R and I, which is obviously I squared RT, because I know the current, I know the total resistance. So let's do that. E is equal to I squared RT. It's 4 over 13, everything squared, multiplied by the resistance outside is 36, and the time we know 240 seconds. And I get here 817.988. So the final answer for energy, let's get it to two significant figures, 820 joules. You can also use any of these two. I mean, we did use this one, and you'll get exactly the same answer. Now let's see how to do that. To do that, we need to find the voltage. So what we really need to find is the voltage across this, which is the terminal potential difference. Now the formula for terminal PD is V is equal to E minus IR. So let's work this out. E is 12, I is the current, which is 4/13, and R is 3 here. So we can work out the terminal potential difference is 12 take away 12/13, and that gives me 144/13 volts. I'm going to leave it like that because it's easier for me to use this for calculations, but if I actually get the value, it's 11 point something 076, which is a little bit less than 12. Why? Because it keeps the remaining amount, that 0 point something, to drive the current through the internal resistance here, 3 ohms. Now let's use this first formula and see if we get the correct answer. E is equal to IV T. Now what's my I? Current here is still 4/13. What's my V? V is 144/13. So let's plug that one. 144/13, and the time is still 240. So let's put this in the calculator, and you exactly get 817.98 which I can call 820 joules. So we have done this one as well. So the only leftover one to do is the middle one. Let's see if that one works too. So E is equal to V squared over RT. So let's plug the values carefully. So V is 144/13, everything squared, over R. Capital R here is 36 times by 240. Let's put this in the calculator, and I got exactly 817.988 . So that again gives you 820 joules. Now this is a really good question where you can actually see how all of these formulae direct you to the exact same answer.